Welcome and bonjour. This is the PostGIS function of the week, episode 3. I'm Maurice, and this week's function is STUnion. What is STUnion? Let's hop into PSQL to look at the function signatures. Already, as you can see, there are 10 variants of STUnion, 5 for raster and 5 for geometry. All the raster variants are aggregate functions. So usually you will use a group by clause in the aggregate variants. The geometry types have 3 scalar functions and 2 aggregate functions. Let me do my usual mundane examples. They're going to be very contrived. I'll do one with the raster variant first. I have a raster table here called Hebron. And it just contains RID and an integer and then the actual raster data type in a column called rast. So let us do this is a very contrived example. All we're doing is basically unioning these 3 rows into one raster. Let's create a new table to display it in QGIS later. Alright, didn't take too long. And when we pop into QGIS, we can look at that. Alrighty, our second example will involve geometries. And I'm going to create 3 relations, a table and 2 views. And we're going to basically see what happens when you union different types of geometries. So for example, if you union a point and a polygon, what do you get? So we're going to create the tables, the views, pop into QGIS, and we can look at that. As usual, since there will be a lot of typing right now, I'll just speed through this. Okie dokie, so I create a schema called demo. I create a table called individuals with a geometry column. Note that the geometry column doesn't have a type def, so it can either hold a point, a polygon, a line. It can hold anything as far as PostGIS is concerned. And then I create 2 views. The first view, called unionized, is actually the union of the entire table. I've added in a function to push it down about 1,000 meters below the individuals table. And then the second view, called resultant geometry type, is just going to give you the type of geometry that comes about from the union. And of course I spelled union incorrect right here. Okay, everything looks to be in order. Great. We can now pop into QGIS and have a look. Alrighty, we are here in QGIS. Let us first take a look at our raster union. So we have the original table called Hebron and our subset table. We can add our subset table directly, and that's what it looks like. And for reference, the initial table or the original table called Hebron, it is much bigger. May take a little while to load. There you go. So Hebron and subset. So that is the raster union. Not much going on there. Let's jump into the vector stuff. Alrighty, so let us try and add the tables. Now the vector stuff is not here, and that is because QGIS likes to have defined types for their tables. Now, as I had mentioned earlier, I didn't define a type when creating the table. So we're going to have to do a little workaround. Pop into the data source manager, look in demo, and we have the three relations here, and they all have exclamation marks. Let us do individuals first. All we have to do is basically enter a spatial reference ID, which is 32733. We're gonna select a spatial type. Let's do point first. Let's add that. Let's do line string next, and then we can add that as well. And then lastly, we can do polygon, and we can add that. If we pop back in to our layer, we will see that we have the three tables. We can group them and call it individuals. We don't need Hebron, do we? Right. Let's group these two as well. Let's call it DEM. That we're not going to be using right now. Alrighty. And we can now go back to the data source manager. And let's unionize. So similar situation. I'm going to choose 32733 as the spatial reference ID. We're going to do one for point, one for line string, and one for polygon. And finally, resultant geometry type. This is going to be a point because I had done a centroid. Alrighty. Let's move this out. Let's So, let me make one more small change. I want this to be rendering every half a second for reasons you will see shortly. Also, let's give it a label because this will be telling us what the geometry type is. Make it a bit bigger. And we can make the symbol very, very small. Alrighty. We can start editing, and we're going to draw a small polygon. Alright, so we have one polygon, so we have one row in the table. If I were to add another polygon, then you'll see down here, this is the resultant of the union. So two polygons that touch will give you one single polygon. If I were to add another polygon that was not touching or overlapping, then we would get a multi-polygon. Now, if I were to draw a line, we will get a geometry collection. So any combination of geometries that are unioned, that are not touching, you will get a geometry collection. If, however, I were to move the line wholly within the polygon, then it's kind of merged into it and it's still just the multi-polygon. Similarly, if I add a point on the polygon, still a multi-polygon, add it elsewhere, it becomes a geometry collection. Polygon. See? Yeah, so that is what happens when you merge stuff. Not merge, I keep saying merge. This is what happens when you union things. So let me remove the polygons. And we're back to a geometry collection because we have a line and 2 points. If I remove the line, or the points rather, then we're back to a line string. And if I have 2 line strings that I'm meaning to turn snapping on for this actually. Snapping toolbar. There we go. Now notice this is a multi-line string. Let me try and get it very exact and see if I draw one line with 2 vertices and another line it does not merge them as you might expect. And if you want to actually merge line strings together, there is a separate function which I will pop up in the right hand corner somewhere. The name currently eludes me. However, points that are on top of each other, let's create a point here. And let's create another point right on top of it. It's still a single point. No, that's 4 points. So if I were to move a point off, it becomes a multi-point. And of course, if I were to draw a polygon that encompasses, it's not just a single polygon. Yeah, so that is how shapes are unioned. And finally, a more realistic example. Let me just get rid of these right here. I have a table here called income. Let me add it and explain it. So this is the country of Namibia, and each of these polygons is a constituency with some income values, just some numbers really, a random number. But each constituency is part of a region. So let us say, for example, we wanted to get the total income by region. We would do a select statement with a group by. And if we wanted to also visualize the entire region as a whole, then we would use stunion. So alrighty, so there we go. So we have now grouped all of the constituencies into their respective regions along with summing the income value. Alright, this was kind of long. Look out next week for ST Makeline.